Hey, good Thursday morning, everyone. I hope you've already read the notes on the ideal gas law and the combined gas law. Here are two problems that are going to be similar to today's assignment that I'd like to solve for us. All right. Number four, what mass of nitrogen is in a 20-liter cylinder, that's a volume, at 18 atmospheres, that's a pressure, and 27 degrees Celsius? All right. This is a good example of having to use the ideal gas law. PV equals nRT. Conditions are not changing. There's one volume, there's one pressure, and there's one temperature. All right? We know we're told the pressure, we're told the volume, and we're told the temperature. We can solve for N. N equals PV over RT. All right? I'll plug in my pressure, 18.0 atmospheres. I'll plug in my volume. It is in liters. That's good. If it were in milliliters, I'd have to change it. And I have two values for R from our notes, but since my pressure is in atmospheres, I'm going to use the 0.08205 liter atmospheres per Kelvin per mole. You don't need to put the units in here. You just need to know how to use them. And my temperature has to go down here too. Temperature always has to be in Kelvin. 27 degrees Celsius plus 273 is going to be 300 Kelvin. Take out my calculator, 18 times 20 divided by 0.08205 divided by 300 comes out to be 14.6 to 3 sig figs. What's my label on this? Well, we're solving for N. It's moles. Liters cancels out, atmospheres cancels out, Kelvin cancels out. We're left with moles. All right? So that's not my final answer. It says what mass of nitrogen. All right? Well, if I have 14.6 moles of nitrogen, remember it's a diatomic gas, I know that 1 mole of nitrogen, I can add up 14 and 14 from the periodic table and get 28 grams of nitrogen. Comes out to be 410 grams of nitrogen. All right, that's an example using the ideal gas law and rearranging it to solve for N. All right, number 5 is interesting. The ideal gas law and the combined gas law can sometimes be interrelated and used differently. All right. Number 5 says, if the tank above is heated to 77 degrees Celsius, what would be the pressure? Well, I could use PVnert again, all right, and solve for a pressure. Pressure is going to be nRT divided by V. I just solved for the moles up here. My moles of gas is 14.6 moles. I'll use 0.08205 again, liter atmospheres per Kelvin per mole. T also goes on top. We heated it up to 77 degrees Celsius. 77 plus 273 is going to be 350 Kelvin, all right? The volume that we're in from above is 20 liters. I take 14.6 times 0.08205 times 350 and divide by 20, and I get a pressure of 21.0. My label for pressure is based on the unit of R I use in here. Is going to be atmospheres. I could have used the other value for R. It's still solved for a pressure, but its units would be in torr, all right? The other way to solve this one is the combined gas law. P1V1 over N1T1 equals P2V2 over N2T2. Well, is there anything constant? Yeah, the number of particles is constant. I can leave that off. And if it's a tank, its volume is constant as well. So the combined gas law, P1 over T1 equals P2 over T2. I could have said, well, above, I had a pressure, P1, of 18 atmospheres when the temperature was 300 Kelvin. what would be my new pressure if I heated it up to 77 degrees Celsius or 350 Kelvin? Cross multiply and divide. 350 times 18 divided by 300. P2 equals 21.0 atmospheres. It's like magic, all right? Hey, I miss you guys. I gotta find a joke for next week. Logan Sprecker's getting tired of getting picked on. All right, take care. Peace out. Keep your stick on the ice.